Here we are going to take a look at a question that says find the total number of permutations of all the 9 letters of the word paragraph. Find the number of these permutations that start and finish with P, have the letters A, E, E together. I have no two of the letters R, G, E, E, E consecutive. So we are going to make an example like this question. However, we'll make a slight modification. We will change this to start and finish with start and finish with an A. Okay. Another restriction. I have the letters E, E together. I have no two of the letters H, G, P, P consecutive. So we'll start with A. So to start and finish with an A, let's set up the visual. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. So start and finish with an A. Yes. So basically what we have remaining are 1, 2, 3, 4, 5, 6, 7 letters, which are actually P and E, R, R, a G, and an H, and another P. So these are the set of 7 letters that have remained. 1, 2, 3, 4, 5, 6, 7. So basically what we are going to do in here is to arrange 7 letters, which has 2 R's and 2 P's. Okay. So basically that can be calculated by say 7 factorial. However, we notice that in those 7 letters, there are 2 R's and 2 P's. Okay, so we've got to divide by 2 factorial times 2 factorial. Because the 2 P's and the 2 R's, when swapped amongst each other, do not create any new arrangement, any distinct arrangement. So therefore, their repetitions have to be divided out. So 1, 2, 3, 4, 5, 6, 7 arrangements and divided by 2 factorial times 2 factorials. Now the A's now can swap. It's possible to swap the A's. Now swapping A's does not create any new arrangement. Start with an A, end with an E. And you can possibly swap the A's. So therefore now, this activity is possible, but when done, does not create any new arrangement. So this has to be that repetition, that repeated arrangement has to be divided out. So this has to be divided by 2 factorial because of the 2 A's. and that will give us 630. So now we're on part B, and the restriction here is that the letters P, P must be together, okay? Must have the letters PP together, all right? So an example of this would be, on bear in mind, we have to use all the letters. Here it says that the total number of permutations of all the 9 letters. So we must use all of the 9 letters. Here we have the two P's together, and then they can be both treated as one, grouped up. So you have 1, 2, 3, 4, 5, 6, 7, 8. Okay, however, bear in mind that they are not 8 distinct objects, not 8 distinct letters. You have 3 A's to contend with and 2 R's. So this has to be taken into consideration. So this basically will be 1, 2, 3, 4, 5, 6, 7, 8 factorial divided by 3 factorial for the 3 A's times 2 factorial for the 2 R's. Yes. Times, because whilst we are arranging those 8 objects, we are also arranging the 2 P's. However, since the 2 P's are together, that's 2 are the same, sorry, that's 2 factorial divided by 2 factorial because the P's are repeated. And this will be 3,360. So bear in mind the 8 factorial is for the 8 objects where you've got 3 A's and 2 R's. That's where the division happening. And at the same time, you are arranging 2 P's, but the P's are alike, so you have 2 factorial divided by 2 factorial. The multiplication sign is for the and. And in statistics and in probability analysis is interpreted as the operation of multiplication, and or is interpreted as the operation of addition. So part C now says that there must not have no 2 of the letters H, G, A, P, and P consecutive. However, there seems to be a problem with this because you already have 3 A's. Okay, so if we make a space with the 2 A's, it's possible for 2 A's to be consecutive. So this question produces a conundrum. We have to make a deeper analysis to see if this is possible. Okay, so I think the best thing to do is to remove this A and leave it as no 2 of the letters H, G, P, P consecutive. Okay, because I repeat, if we put an A here and we don't want to make the A's consecutive, bear in mind, here's how our working is going to be. We're going to have an a space, and then an E, a space. All right. A space and then an E, a space and an E, another E, right? Because we have 2 E's remaining, a space. And what is possible is that when this E selects a space, it can happen to come here. And then it violates this restriction. All right, so best we leave it as one of the letters creating the spaces. So remove it from here so that conundrum, this paradox will not, or this contradiction will not happen. Okay, so we have the A's making the space, the R's, the two R's making the spaces. Okay, now the G and the H and the two P's, the G and the H and the two P's will be the ones selecting the species. All right, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, okay, of the letters all being utilized in this analysis. So the selection, the choosing will be done by 4 letters from a total of 1, 2, 3, 4, 5, 6 spaces. So we have 6, choose 4, 4 choosing 6 spaces. All right. And at the same time, after they have select those spaces, they have to be arranged. So you are arranging 4. However, that's 4 factorial. However, there are 2 p's present. So we have to divide by 2 factorial. And at the same time, the 1, 2, 3, 4, 5 letters who created the species are being arranged. However, there are 3 A's. So there's a division happening. Once the letters are repeated, there's a division happening times the 2 R's. And that should give us our calculation. So let's look for the combination calculator and factorial calculator. So 6 choose 4 is 15, according to this calculator. 4 factorial divided by 2 factorial, that will give us 12. 24 divided by 2. 5 factorial divided by 3 factorial times 2 factorial, that's equal to 10. So we've got 10 times 12 multiplied to 15. And that gives us 1800. So here's our solution to this example.